Here we have the first question. They give two graphs of function f and function g. This dashed line is a tangent line of the graph of f at different points. For example, this line is a tangent line of this graph at the point 1, 2. This is a tangent line at the point 2, 3. And here you have the graph of g. They give us 2 points, and then at that 2 points they draw the tangent line. Now the question is, what is the derivative of the compositions? So this is the composition function of g compose f, so g of f of x at x equal to 1. So they give us the 3 different composite functions: g of f of x, g of f of 3 minus x, g of f of 3 minus x squared, and at x equal to 1 or 2. Let's do the first one first. We need to find the derivative of this. So recall that this is a composition of 2 functions. So we can use chain rule to compute the derivative. G of f of x prime is g prime of f of x times f prime of x. So this is the composition you need to know. So g prime of f times f prime, or if you don't remember that, you can draw the diagram. X send to f of x first. That's what we do. We need to compute this one first, and then you call this u. And then you send u to g of u. Let's call it y. So by chain rule, you know that dy over dx, dy over du times du over dx. So dy over du is just g prime of u. G prime of u is g prime of f of x. So here's dy over du, g prime of u, du over dx, f prime of x. And then g prime of u equal to f of x times f prime of x. So for now, just remember this formula and we can use it. Now we need to compute this one. When x equal to 1, you need to compute this one and this one. The derivative f prime of x, we can compute that at the point x equal to 1. So this means you need to compute the derivative at x equal to 1. So we need to compute this one and this one. Now let's compute this one. The first term, g prime of f at 1. So we need to find what is f at 1. F at the point 1 here, which gives us 2. So that is f at 1. G prime at 2. That's the first thing we need to compute. What is g prime at 2? The second thing we need to compute, what is f prime at 1? F prime at 1. So these are 2 questions we need so that we know the derivative of this. So let's do it for f and g. F prime at 1, g prime at 2. F prime at 1. This is the slope of the tangent line at this point, x equal to 1, y equal to 2. The slope of this tangent line passing through this point and this point. So know the coordinates of 2 points, you can know the equation of the tangent line. So let's do this function f first. So tangent line is passing 2 points. You can find that. The f prime is on the slope of the tangent line to the graph of f at the points x equal to 1, which means the points 1, 2. Now, this is this line. We need to find the slope of this line. So, if we have an equation of a line passing through this line, let's call it the slope tangent. Let me call this line L or L1. L1 equals L1 is passing through, let's call it P and Q. P in L1, Q in L1. P has coordinate, say x, P, y, P. Q has coordinates xq, yq. Then the slope of L1 is yq minus yp divided by xq minus xp. Now, if you can remember this, is good. If you don't, here's how we can understand why we have this formula. The line L1 of the form, say, y equal to a times x plus b. So P and Q both belong to L1. So they are both on the line L1. So the coordinates of P and coordinates of Q satisfy the equation of L1. Yp equal to a xp plus b. Yq a xq plus b. You can take this minus this side by side. Yq minus yp equal to a times xq plus b minus a times xp plus b. A times xq plus b minus a xp plus b. This b and b cancel out. A in common, you have a xq minus xp. A is the slope of the line. So that's why you see that a, the slope, equal to yq minus yp divided by xq minus xp. So that explains why the slope of L1 is of this form. You can use this again and again in this example. Let's find the slope of L1. L1 passing through 2 points P and Q. P has coordinates 1, 2. Q has coordinates 3, 5. 3, 5. P is 1, 2. Q 3, 5. Now we get the slope of L1 by the formula here. The slope of L1 yq minus yp 5 minus 2 divided by 3 minus 1, 3 over 2. This is the slope of the tangent line at the point P. The slope of the tangent line at this point P. At 1, 2. So this is f prime at 1. F prime at 1 is 3/2. So we computed f prime at 1. F prime at 1. Now we need to compute g prime at 2. We do similarly. Here's a graph of g. G prime at 2 is what we need to compute. X equal 2, y equal to 1, so that is the point, the slope of the tangent line at this point. Slope of the tangent line. Let's call this tangent line L2. This line passing through the point here, the tangent line L2 to the curve, to the graph G at the point 2, 1. So this tangent line L2 is passing through this point and this point. So we know that 2, 1 belong to L2. 0, 2 belong to L2. So the slope is two minus 1 divided by 0 minus 2. 1 over negative 2 minus 1/2. This one is G prime at 2. G prime at 2. So I compute that G prime at 2 equal to negative 1/2. F prime at 1, 3 over 2. Now we just plug in this formula. So this is G prime at 2. G prime at 2 times F prime at 1 equal to minus 1/2 times 3/2 negative 3 over 4. So we finish the first one. Now we can do the second one. What is the derivative of this function at f? So we finish the first one, now let's do the second one. What is the derivative of this function as x equal to 2? Now we use chain rule. So now think of that as a chain rule. This one of f of, let's say, whatever function is it you call here. Compute this derivative. G of f of 3 minus x prime. So now if you're comfortable with the chain rule, now we know that. Let's do this one as a function g of f first. G prime at f 3 minus x times f at 3 minus x prime. So that I do the chain rules one times for this one, this pink function here. Now I need to do the chain rule another time for this this function 3 minus x here. G prime f 3 minus x, that's the first term, keep the same. The second terms, by chain rule, we have f prime 3 minus x times 3 minus x prime. So this is, these two keep the same. The last terms, 3 prime 0 minus x prime minus 1. So this is what we need to compute. Now they ask us at the point where x equal to 2. So we compute that derivative at x equal to 2. X equal to 2. So this means this one at x equal to 2, at x equal to 2. So the derivative we need to compute g prime f of 3 minus 2 f prime x equal to 3 minus 2 minus 1. G prime of f of 1 times f prime of 1. So this is f prime at 1 and f at 1. We look at the graph. F at 1 equal 2. So f at 1 equal to 2 minus g prime at 2 times f prime at 1. F prime at 1. So this is slope this line. We computed that in the previous example. So let's look at f prime at 1, g prime at 2. F prime at 1, g prime at 2. We've computed both of that before. F prime at 1 and g prime at 2. And this one would give us minus 1 over 2 times 3 over 2, 3 over 4. So that is the answer for the second question. Now let's do the last question here. We need to compute the derivative of this function at x equal to 2. You do it similarly. G of f 3 minus x all square, now prime 2 times this times this one prime. So this one equal to 2g f 3 minus x times, we do the chain rule again, g prime at f at 3 minus x times f 3 minus x prime. And we need to do chain rule one more time. F prime 3 minus x prime, which is minus 1. This one is minus 2 upon of this. Now they ask us to compute that at x equal to 2. Derivative at x equal to 2. At x equal to 2, so we just plug in the values x equal to 2 here. X equal to 2. So this is minus 2 times g of f of 1, g prime of f of 1, f prime of 1, f of 1 equal to 2. G of 2, g prime at 2, f prime at 1. So let's look at the graph. G at 2 2 is here, g at 2 is equal to 1. Minus 2 times 1, that is for the first term. Second term, g prime at 2 minus 1 over 2. F prime as 1, 3 over 2. Minus 2 divided by minus 2, 1. So the answer is 3 over 2.